Hi, welcome to another Tech Up podcast. So, when I first heard about the Neuralink a few years ago, I thought it was pie in the sky. But after watching the presentation and thinking about it, a lot of this stuff has actually been done before. It's nothing new, it's just been done a lot better. So, let's take a look at what the Neuralink is, how it works, and the new feature that we could all be facing. So, what is Neuralink? Musk states that human cognition has two major systems: the limbic system, where our emotion, needs, and wants are processed, and then the cortex, which involves thinking and planning. The neural link in its final form is to be the third layer. On top of this, a digital super intelligence layer, augmenting ourselves with computers and eventually artificial intelligence. Depending on how you look at it, we already have this layer in form of our phones and laptops. You have all heard the saying that we have all the world's information at our fingertips. The bottleneck and all of this is how we interface with that information. Fingers and speech are too slow and a very low bandwidth form of communication between us and our devices. A much faster way to get this information would be directly. This is called the brain-machine interface. The Neuralink is an effort to solve this problem. It's already been a massive multidisciplinary effort. It includes scientists, doctors, electrical engineers, and surgeons, and more. So, how does it work? So, our brain consists of neurons firing all the time in response to electrical signals sent. When we see, hear, move, walk, or think, whenever a neuron fires from these electrical signals, a tiny electromagnetic field is present. Basically, Neuralink is going to tap into these tiny electrical fields generated as sinus junctions in the brain. It's going to interpret this analog data as ones and zeros to be used in the digital world. The neuron pulses will be detected using tiny threads about 1/10 the cross section of a human hair, or about the size of a neuron. Each thread is going to be installed with a robot, so it's not going to burst blood vessels or cause trauma. The needle insertion is 24 microns in diameter, much smaller than the state-of-the-art in deep brain stimulation. Such surgeries have been done before for deep brain stimulation for Parkinson's sufferers. Though these traditional methods have a 1 in 100 chance of causing a severe brain hemorrhage, a smaller footprint should make things much safer. The state-of-the-art for Parkinson's deep brain stimulation has around 10 electrodes. The Neuralink contains thousands of electrodes. These electrons need to be less than 60 microns away to detect a fire in the neuron and serve as the interface that reads data from the brain and sends data to the brain. The processor for making all this work is something called the N1 chip. The N1 chip reads analog brain signals, amplifies them, digitizes them, processes them, and then sends it out to a pod device behind the ear. The pod device is the only thing that's going to be upgraded, and the implants stay as they are. Remove the pod and everything shuts off. The N1 chip is 4x5 mm, low power, and has a built-in hardware for processing the brain signals. It can read 20,000 brain samples per second. So these are real raw signals coming from a neural link hooked up to a brain. What the scientists are looking for are spikes and voltages. When a neuron fires, this is the fundamental element of communication within the brain. An algorithm can detect these spikes in real time, decode them, and make sense of the vast amounts of data coming in. The system can not only read data from the brain, but can also write data. To do this, a signal is run through an electrode near a neuron, causing that neuron to fire. This kind of thing again isn't new and has been done since the late 1950s. It's actually the basic technologies behind the cochlear ear implant, the one that helps restore hearing. The information inputted into the brain doesn't have to be perfect. Because of neuroplasticity, this means the brain learns how to use the new information. Reading data from the brain and inputting data into the brain can be done. Already, this kind has been used to treat things like Parkinson's and epilepsy. But future applications can include things as far as depression and chronic pain. Further applications couldn't create a function and memory. The original plan for Neuralink is to connect for N1 chips with thousands of electrodes, and coming from each chip, signals will be sent via Bluetooth to the pod device behind the ear, and it will be controlled by a phone. The first goal is to get patients to be able to control a mobile device, a phone, mouse, or a computer keyboard. The Neuralink will show up as a regular Bluetooth keyboard or a mouse. They want to make people fully independent of their caretakers. This sounds lofty, but has already been done before with a technology called the Utah Ray. With only 100 electrodes, patients are able to text other people and control tablets with their mind. Remember, the Neuralink has thousands of electrodes, resulting in a cleaner, more reliable signal for more complex applications. The first application for Neuralink is to tap into the primary motor cortex, the part of the brain that sends signal down to the spinal cord and onto the muscles to drive the movement. It will start with simple things like mouse and keyboard, but could also be used to read signals from all the movement, even speech. And finally, it could be used to restore movements of someone's own body. Material science team wants to use the materials or properties that would make the brain not only accept the Neuralink but think that it's a part of itself. The team has already released a paper of recording, reading, studying data from brains using the N1 chip. It's fairly controversial, but early tests on monkeys have been successful. Human patient trials are set to start by the end of 2020. The target patient will be a quadriplegic due to spinal cord injury. The main hurdle so far has been FDA approval for implantable devices. So the future of Neuralink will be in 3 stages. Stage 1 is to understand and treat brain disorders starting with people with serious medical needs. Stage 2, preserve and enhance one's own brain. Stage 3, full brain machine interface. In the future, that could even be kind of an app store for programs that you can download and control with your brain. Other possibilities from the presentation include a new kind of a communication, kind of like telepathy or downloading the memories of someone who's familiar with the city, so that when you go to the city, even you feel familiar with it too. The possibility is a kind of endless. But of course, these are very early days and we hardly understand anything about the brain right now. Although what the Neuralink is basing itself off has already been done in the medical field for decades. What they are proposing is a giant leap. Above all of that, it's going to be a long road to get there. See, some obvious questions remain. Is this ethical? Should we do this? What about the risks? Well, for that last one, in terms of risk, for Parkinson's, deep brain stimulation and other such procedures seem to be much more risky, though there's not a lot known about what kind of technology that Neuralink is proposing. So what do you guys think? Do you think it's an interesting idea and should we pursue it? Or do you have any kind of reservations? I'm gonna leave my opinion out of this one. So thanks for hearing my podcast. I hope you learned something from this. It's definitely an interesting time we are living in the moment. If you want to hear more stuff like this or anything on the lines of business, science and technology, definitely subscribe to Tech Up Podcast on Spotify, Google Play Podcast, iTunes and Anchor. You'll find a lot more interesting stuff here. And I'll catch you again soon for the next episode. Cheers guys.